Hey everyone, in this lecture we're going to be talking about how to use the z-table to find a z-score given the area to the right of that z-score. So this is going to be a little tricky, so let's get started. So in the last lecture we talked about how to find the area to the right of a z-score using our table, but now I'm actually giving you the area to the right of a z-score and I want you to find the z-score that has that corresponding area to the right of it. So let's work through an example of how to do this on the computer. See you there. So far we've worked with areas to the left of certain z-scores. So if I give you a z-score and I ask you to find the area to the left, we know how to do that. We can just use our chart. But let's say I wanted you to find the area to the right of 1. Now, first of all, notice that I used the greater than symbol, and I'm going to explain why I use the greater than symbol here. So 1 is right there, let's say. But when I talk about all the values that are greater than 1, these right here on this number line, these are all my z-scores. Now, which values are greater than 1? Well, it turns out that basically all of these values right here. And so the probability that z is greater than 1 would be represented by the area above that region, which is this area right here. Now I have bad news. The area to the right is not represented in my chart that I showed you. My chart can only find the area to the left. So unfortunately, I can't solve this problem right off the bat because my chart only tells me this area. So that's okay though, because if you notice that this purple region and this red region together make up the entire area under the bell curve. And remember, the entire area of this bell curve should add up to 1. So the idea is that purple region plus the area of that red region should equal 1. So that's a really important fact because we're going to use some geometry here to try to figure out the area of this red region because that's what we're trying to figure out. What is this value? What is this area of the red region? So let's go to the chart and let's find the area to the left of z equals 1. So I'm going to pull up my keyboard and switch over to that tab. All right, so we need to find z equals 1. So let's see here. I'm going to pull up my editing. So z equals 1 is right here, 1.0, and then the hundredths place is also 0. So it would be 0.8413. And that makes sense because if we go back to that illustration that we had earlier, 0.8413, I'm going to remember that. This area right here is 0.8413. Now why does that make sense to me is because this purple region should be greater than 0.5 because it contains the entire left half of this bell curve. Remember, each side of the bell curve, the left and the right areas add up to 0.5. So this purple region is a little bit more than 0.5, which makes sense because this number is more than 0.5. Now this red region should be less than 0.5 because it doesn't contain at least half of this bell curve. So what would this region be? Well, I know that these two regions should add up to 1. So I'm going to actually, this region right here, this purple space, we just found what that area it was. It was 0.8413. So 0.8413 plus the area that I'm trying to find, this red region, equals 1. So how do I find that red region? Well, I used areas like colors to represent what these unknowns were, but if you want to think about an algebra, if it helps you, put an X there. That X just represents whatever my constant is that I'm trying to find here. So to solve for X, I just have to subtract by 0.8413 on both sides because both areas add up to 1, so this area would be the difference that is left over? What is the gap between 1 and 0.8413? Now, I'm going to work off of this algebra just in case you're still a little bit lost here, so I'm going to erase this temporarily. Because I want to work with this algebraically. Basically, I'm going to subtract 0.8413 on both sides of this equation to solve for x. So these two cancel, and I'm left with x equals 1 minus 0.8413, which is 0.1587. So that region is 0.8517. And I'm going to use a different color because we're getting a lot of blacks and it's getting a little boring. 0.1587. So that red region's area is 0.1587. Now I'm going to generalize this example to say something real quick. The idea is that the probability that z is less than any number, well, we'll say that number is c. Doesn't really matter what the number is. You can put anything for that c. Plus, so that's the area to the left plus the area to the right, which is z is greater than c. This should be equal to 1. Now I'm gonna manipulate this equation so that you can get a better understanding of the formula that a lot of people use on different cheat sheets. But if I ever want to find the probability that z is greater than a value c, this is just 1 minus the probability that z is less than c. So these two basically say the same thing. They're the same formula, just rewritten. I just took the first formula and subtracted the first term on both sides. So I just moved that over to the right side of the formula, which is why there's a minus here. But you can think about it geometrically. That's the way I like to think about it because we're going to play with geometry a lot later on in this course. So just keep that in mind. The idea is, again, this really hinges upon the fact that the total area, the left area and the right area, add up to 1. So we can't find the area to the right with our chart because the chart only tells us the area to the left. But because we know the area to the left, we can figure out what the leftover area is, which is the area to the right. So that's kind of how this plays out geometrically. Thank you guys so much, and I hope this example helps. See you in the next video. You just watched a video from More Learning. We provide free math videos, and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. And put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.